Why waste time in commute and spend a lot of money for iitjee coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. iitjee. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the PYQ discussions on JEE Advanced Papers. Here I have got a problem from JEE Advanced Paper 1 2023. This question says a bar of mass m is equal to 1 kg and length capital L is equal to 0.2 meter is lying on a horizontal frictionless surface. One end of the bar is pivoted at a point about which it is free to rotate. So this is a representative figure I have drawn for your understanding. Let us try to understand this. So this is the rod having length L and this end is pivoted end about which the free end can rotate with angular velocity omega, let us say. A small mass, small m is equal to 0.1 kg is moving on the same horizontal surface with 5 meter per second speed on a path perpendicular to the bar. So this is the small mass which is moving with the velocity say v0 is equal to 5 meter per second and it is moving perpendicular to the length of the bar. It hits the bar at a distance L by 2 from the pivoted end and returns back on the same path with the speed v. So the question says the small mass hits this perpendicular to this bar, elastically hit this and returns back with the speed v but through the same path. After this elastic collision, the bar rotates with an angular velocity omega. Which of the following statement is correct in this situation? Okay, so you can see these options: angular velocity, and this is the velocity of the small mass with which the small mass is returning back after collision has to be calculated, and this angular velocity omega is for the bar. So here, since this small mass is hitting this bar and it is moving, so therefore we cannot say that external force is 0. We cannot say that. It is actually non-zero. Therefore we cannot use linear momentum conservation. So we should use here angular momentum conservation. Okay, so let us try to apply angular momentum conservation. So initial angular momentum will be just due to this small mass m v0, okay, and this is hitting at L by 2, okay, L by 2. This is actually initial angular momentum, okay, m v0 L by 2. What is the final angular momentum? See, final angular momentum will be due to both. See, for the bar I can write I omega because it is rotating with omega angular velocity and it has, see, I is the moment of inertia and this is moving or returning back with velocity v, so I can write along the same path, so I can write m v L by 2. Okay, so what is this I? I have to find out moment of inertia of a bar about an axis passing through one of its its end and perpendicular to the length of the bar. So that is actually m L square by 3. Okay, and this we know m v L by 2. Now if we equate these two, okay, if we equate, so what we write here, m v0 L by 2 is equal to this one. Okay, alright, so applying angular momentum conservation, we get this equation number 1. See, in this equation I have two unknown quantities. One is this one, another one is this one. I have to calculate both, but I have got only one equation. So here we have to use the another clue, that is the elastic collision. So this collision was elastic, so E is equal to 1. Okay, and this is actually velocity of separation. That means velocity after the collision, velocity of the small mass minus velocity of the bar. Okay, velocity of the bar. So this I have to write and divided by, see, initially when it is called approach, this is velocity of separation and velocity of approach. So this bar was not having any velocity, so I can write this is v0. So from here, look what I get. So Vm, mass of the bar is V, it is given already after collision. And see, for this I will get capital L by 2 into omega. Okay, L by 2 into omega. This is what I will get divided by V0. That means, you will get a relation between V and V0. Okay, so I can just replace this V with V0 and omega from this equation 2 into this equation 1. Okay, so that I get only one unknown quantity omega. So if I do that, so what I will get, let me go here. See, I have here m v0 L by 2. The equation I am writing here, the first equation. Okay, then m L square by 3 into omega minus m v L by 2. This is what my first equation. So second equation is v is equal to v0 minus L omega by 2. Okay, L omega by 2. I'll just put this here. Okay, look, if I put this, and then I'm sorry, this is 3 into omega, and if I solve for omega, see, I'll get, upon simplification, v0 into L divided by m L square by 3m plus L square by 4. Okay, so this is what I'll get. Now, we have been given v0 is equal to 5 meter per second, and then you have been given L is equal to 0.2 meter, and small m is given as 0.1 kg, and capital M is given as 1 kg. So if you put all this, so what you get, you get 300 by 43. Okay, and this will be obviously rad per second, and if you divide it and simplify, you will get something like 6.976 rad per second, so which is approximately 6.98 radian per second. Okay, so once you get this, let us put this for V here. If I want to get V, then you get V is equal to V0 minus omega L by 2, right? So L is, L is 0.2 meter, and then L by 2 will be 0.1 meter. So omega L by 2, so V0 is given as 5 meter per second, and this is 6.98 radian per second, okay, and this is 0.1 here, so it will give you approximately 4.30 meter per second, okay. So look, then what we get, omega is equal to 6.98 and V is equal to 4.3 meter per second. So these are the set of answers for this question, okay. Look the options here. So I have got the first option to be correct for this problem. Thank you.
Why waste time in commute and spend a lot of money for iitjee coaching? Parents, do you want your kids to achieve top scores in iitjee? India's leading online NEET coaching 100% success iitjee. At TeenEinstein, we focus on iitjee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.